Hello, my name is Mark Last. Together with my colleagues, Chang Liu and Armin Shmilovich, we are presenting today MND, a new dataset and benchmark of movie scenes classified by their narrative function. The setting of our research is that the success of Hollywood movies is partially attributed to the notion that filmmaking constitutes both an art and an industry. It's an artistic tradition based on a standardized approach to cinematic narration. The field of video understanding is focusing mainly on recognition of low-level information, such as a person is driving a car. On the contrary, the field of narrative understanding deals with more high-level information, like a person is going back home from work, which of course is a more difficult task to recognize than just identifying that a person is driving a car. More specifically, our research is focused on identification of narrative structure of a Hollywood movie. What is the goal? The goal is to recognize the narrative structure of a movie by recognizing the key events in that movie via scene classification. We have several contributions, novel contributions in our research. First of all, we introduce a new task for movie analytics, identifying the latent narrative function of each scene in a movie. We also introduce the first benchmark dataset of movie scenes labeled by their narrative function, and that dataset is released to the research community. Finally, we demonstrate that a movie's latent story structure can be automatically detected using conventional machine learning algorithms and a limited set of some relatively simple scene features, which can outperform a strong temporal distribution baseline. According to a book by Blake Snyder, which is called Save the Cat Goes to the Movies, each scene can be associated with one of 15 story beats. These beats represent the progression of a movie storyline. The numbers that you can see on the left represent the number of minutes since the start of a typical 110 minutes movie. Just briefly, a few examples. The setup beat, the setup scene class introduces the hero and other movie characters, the stakes, and the goal of the story. A catalyst beat knocks the hero out of his or her before world that was shown in the setup. And the third example, a beat which is called B-story, which represents a different story, such as a love story, where the hero deals with her or his emotional side. Our movie narrative dataset, called MND, includes 45 cinema movies from the movie graph dataset. The scene splitting is also based on the information in the same dataset. We rely on 119 human annotators who labeled about 6,500 different scenes. The available labels included the 15 story beats mentioned in the presented on the previous slide, and also a label for another beat. Eventually, the set of labels was reduced to 12 only. We also had 9 movies with gold standard labeling, performed by expert scriptwriters. On average, we had 3 movies labeled by the same annotator, and each movie had at least 5 distinct annotators. In our machine learning experiment, we have split the dataset of 45 cinema movies into 5 balanced folds. We applied feature engineering to calculate 7 different features for each scene, and we compared the accuracy of a majority rule and the label position benchmark to XGBoost classifier. So XGBoost classifier produced F1 measure of 0.31, which was statistically significant above a static baseline classifier. This indicates that machine learning algorithms can learn the sequential character of key elements in a movie storyline. The value of scene classification by the narrative function is in extracting the high-level abstract concepts associated with each story type. And this classification model may be probably enhanced with more elaborate features such as character emotions and audiovisual scene characteristics, including, for example, background music. And this dataset can be used to detect even higher level narrative concepts. Thank you very much for listening. We'll be happy to answer your questions.